This Vivado Quick Take covers implementing the design. You will get an overview of the implementation process, setup, running, and checking results. This diagram shows a high-level view of an RTL-to-bitstream flow. Starting on the left, synthesis transforms a design's RTL source code to an optimized netlist, resulting in the synthesized design. Implementation maps the synthesized design to physical device resources, and then the last step is bitstream generation. In this quick take, we will focus on implementation, which is the process of mapping the synthesized design to physical resources of the target device to create the implemented design. Implementation consists of multiple steps, each step corresponding to a tickle command. These steps are logic optimization, power optimization, placement, physical synthesis, and finally routing. We will cover these steps in a bit more detail later. If you have a Vivado RTL project, you can run implementation after synthesis. If you use external synthesis, an easy way to start is the Create New Project wizard from the Vivado start page. Let's create a new project. We'll just keep the default name Project 1 and create a post-synthesis project since our source input is a synthesized netlist. Next we add the source files, usually a single netlist in structural Verilog or edif. Ours is edif. Then we add our XDC constraints file with both timing and physical constraints. Finally, the target device selection. Our choice was automatically extracted from the edif netlist. Review, then click Finish to create the project. Before we run, let's review the implementation settings. Here we see the implementation commands in the order they are run, along with their default options, which represent a strategy. The commands are opt design, power opt design, off by default, place design, phys opt design, which is also off by default, route design, and write bitstream is included here for convenience. For each command, you choose option values or specify them using more options. Each has tickle pre and post to run scripts before and after a step. For example, if you wanted to report timing and utilization after opt design. Vivado has other preset option combinations available from the strategy dropdown. If we choose high effort physical synthesis, the effort level is high for both place design and route design, and phys opt design is enabled. Now that we're ready to run, click Run Implementation to launch. This loads the synthesized design and applies constraints, then automatically runs a sequence of implementation commands based on the strategy. You can monitor progress in the Project Summary, Log tab, and Design Runs tab. After implementation is finished, be sure to review messages, especially critical warnings which indicate serious design issues or invalid constraints. You can view reports for utilization to see how much of the device resources are used, and the timing summary containing analysis results against design constraints. Review the route status report to check if there were problems routing the design. Finally, you can load the implemented design for interactive analysis. The device editor now shows the mapping of cells to physical locations. You can switch to the detailed view, which displays the routing resources as well. You can run report timing summary, and cross-probe between timing paths and physical device views, and schematics. Now let's look at each implementation step in a little more detail. Opt design performs logic optimization with 3 enabled by default. Retargeting, which changes one cell type to another to aid downstream optimization. Constant propagation, where logic constant values are propagated to reduce combinational and sequential logic. And sweeping, which removes cells with no loads. Other optimizations to reduce logic include remapping and area-based resynthesis. These are included when running with effort level high and area mode. The verbose option is good for analysis. You can run opt design with options to enable only certain optimizations. Run optdesign-help to see the complete list of options. Power opt design restructures logic to reduce dynamic power consumption. Intelligent clock gating optimization creates fine-grained clock gating or logic gating signals that neutralize unnecessary switching activity. Report power opt provides a detailed optimization report. Place design, which can be run with different effort levels to trade runtime for potentially better results, places cells at optimal locations in the device, simultaneously considering timing, wire length, and congestion. Cells with fixed location constraints are placed first, then I/O ports and global clocks. Then come global and detailed placement, packing, and post-placement refinement. When running in non-project mode, it is recommended to check utilization and estimated timing after placement before moving on. PhysOp design further improves placement results with physical optimizations such as logic replication to reduce fan-out delay. PhysOp design only tries to improve the worst paths, not all paths. Route design maps nets to routing resources, working efficiently to achieve both setup and hold timing requirements while avoiding routing congestion. The result is an implemented design that can be used to generate a device bitstream. Route design can be run with effort levels similar to place design. Route design has many different options, as shown by running route design-help. Route design also has a reentrant mode that is used to route or unroute a subset of nets, many or one at a time. So to review, implementation is the process of mapping the logical synthesized design to the physical implemented design. Implementation consists of multiple steps: logic optimization, power optimization, placement, physical synthesis, and routing. This concludes the Vivado Quick Take on implementing the design. Thank you for watching.